Hello, and welcome to the Franklin Effect. I'm Dr. Franklin. That's me. And be sure to hit the subscribe button below. Help me get to 1,000 subscribers. Also, I invite you to leave comments or contact me at thedoctorplace@gmail.com. Hello, and welcome to episode 5. This one we're going to talk about surplus, the time value of money, or when is $5 not $5? So let's do something different. Let's actually get a definition of surplus. I typically use the Oxford Dictionary because it's used by Google. What you get in their definition is an amount of something left over after requirements have been met. Then it goes on to say an excess of production or supply over demand. Now, I would say that it should probably be supply minus demand, but you get the picture. In a prior episode, we illustrated that you should definitely be getting surplus, meaning when you show up for work, you get paid more than what it costs you to be there and more than what your daily requirements are. Now, when we're young, we might temporarily work simply to meet our costs of everyday living. But at some point, you have to start thinking about your retirement. And that's why you need to actually earn more than what your daily costs of living are, so you can have something when you can no longer earn money. Talk to your financial advisor about that. So let's talk about the time value of money. It's kind of a big deal. It's a very important thing to understand. It can take a little bit of work on your part to understand it. I find a great resource to be Investopedia.com. And in fact, if you Google time value of money, you're most likely going to be directed to that site. The basic idea of time value of money is that when you get paid and that money is in your possession, at that exact time that money becomes yours is the exact time when it is worth the most to you. Over time, that money will bring less value. So in answer to the question, when is $5 not $5? Basically, the second it's put in your possession. Because at that time of the transaction, you agreed that you were owed $5 and the other person agreed that what you did was worth $5. But that $5 starts losing its value once it becomes yours. It actually was losing value while it was in the other person's possession too. But let's say that other person had that $5 but kept it for 20 years. Then after 20 years, they gave you the $5 in exchange for some service. That $5 was worth way more 20 years ago than it is right now. Please, whatever you do, don't stop watching now and then go spend all your money. That's not what this is about. In fact, it's to encourage you to not just go out and spend all your money. So where does money lose value? When you recall from a previous episode, whenever there is a translation of energy or transformation of energy, there is a loss. Just like your car engine heats up when you're driving it down the road, that energy is lost forever in terms of propelling your car forward. Similarly, transactions cost money. How often do you go to an ATM machine and have to pay a fee to withdraw the money? That's because these machines cost money and there's a cost of electricity and things like that, so there is a cost to a transaction like that. Most banks don't charge their own members that cost and only do so for non-members. It's only important to understand that whenever there's a transaction or a translation or a transformation of energy, there is a loss of energy. And you remember that that money represents an amount of energy that came from the sun. And energy can be neither created nor destroyed, but it can be made useless. And by useless, it means it's unable to create work or perform work. Inflation. That's another way money loses value. There's nothing you can do about inflation. That's going to happen to your money. So that guy that held that $5 bill for 20 years lost a lot of its value to inflationary losses. Inflation is basically a change in price over a change in time. If you compare the price of bread 20 years ago to the price of bread today, you'll see the effects of inflation. Now, before we get into too many different equations, I also want to talk to you about the opportunity cost of holding on to money. Instead of just holding on to that cash in your pocket, you could put it into a savings account or you could buy something that has value, or you could invest it in the stock market. The opportunity cost of money can be quite significant. It has been said that the historical return on the stock market is 7% per year. Let's go into an equation here. Let's look at what the future value is of that $5 when compared to inflationary losses and compared to opportunity losses. The first thing you see here is an equation that says FV equals PV times 1 plus I over N and then to the N times T power. Okay, FV equals future value, PV equals present value, I equals interest rate, N is the number of compounding cycles, and T is the number of years. Okay, first let's just look at inflation. Inflation, let's say, is 2% over the last 20 years. It's probably higher than that, but this is just an example. And let's just compound it once a year. Because this is a loss, the interest is negative. Now you see in the first part of it, we got future value equals $5 times 1 minus 0.02 to the 1 times 20th power, because we're only going to compound once a year. And that simplifies to $5 times 0.98 to the 20th power, which simplifies to 5 times 0.067, which equals $3.35. So as you can see, when you had $5 20 years ago, it was worth $5 to you. Then you kept it for 20 years in your pocket. It's now worth only $3.35 relative to those dollars 20 years ago. Now what that means is the amount of stuff you could have bought 20 years ago with $3.35 you could now buy for $5. Energy has been neither created nor destroyed here, but it has been rendered less useful. The causes of inflation would be a totally different lecture. I think we can all understand that inflation exists though. Here is the same equation written in a different way. Here we're trying to find the present value of $5 20 years from now. You get the same thing. The present value equals future value divided by 1 plus the interest rate to the nth power, which equals $5 divided by $1.02 to the 20th power, which equals 5 divided by $1.49, which equals $3.36. And the difference is due to rounding errors. Either way, inflation reduces the value of your money the instant it hits your pocket, wallet, bank account, or otherwise comes into your possession. And because it's yours, it's losing value only to you. When it was in the other person's possession, those losses belong to that other person. So if that person had $5 20 years ago, they only got $3.35 out of it today. Obviously not a good investment. Let's switch to batteries instead of money for a second. If you charge up the battery and let it sit for a year and come back, is it still charged up? No, it's not. Even though a battery, just like money, is a storage form of energy, over time that energy dissipates and loses its value, loses its ability to do work. That's exactly the same thing that's happening to your money with inflationary losses. Once you get some usable energy stored up, it's not usually going to stay there for long. Energy always tries to reach its lowest state. Electrons sitting around in a battery takes organization and energy to actually maintain. When that energy is no longer applied to it, it dissipates. It's lost. It's neither created nor destroyed, but it no longer has the ability to do work, so it's otherwise been lost to useful purposes, just like the heat of the engine of your car. As you can see, the laws of economics and the laws of physics are the same thing, and that's because money, which is the main subject of economics, is a storage form of energy. Now let's look at opportunity cost of that $5. The historical returns over 100 years in the stock market is 7%. What that means is if you put your money in the stock market 100 years ago and came back and looked at it 100 years later, your value would have increased by 7% per year. So let's look at that. Relook at the present value of my $5 as being $5, and I'm going to put it in the stock market and expect to get about 7% per year. What's my $5 worth 20 years from now? Go back to that very initial equation about future value. Future value is going to equal present value times 1 plus 0.07 to the 20th power. Since we're simplifying things by compounding annually, I've simplified the exponent to 20 since we're talking about 20 years. That means 20 compounding periods. Here you see I've worked it all out, and I've gotten $19.35. So that money in the stock market is going to be worth roughly $19.35 in 20 years. So as you can see, your choice is to let it sit in your pocket and be worth only $3.35, or put it in the stock market and let it be worth $19.35. So to answer the question, when is $5 not $5? The answer is essentially the second it comes into your possession. If you can invest it in the stock market from the time it takes you to take possession of the $5 and get it into the market, you're losing at the inflationary rate. The minute it hits the stock market, it's going to be gaining at the risk return rate, which is historically 7%. Keep in mind, sometimes the risk return rate is negative, and you can certainly lose money by putting it in the stock market, but over time, and in the long run, you generally get a return of about 7%. Keep in mind, it's called the risk market for a reason. As long as you have a well-rounded portfolio, or the best case is to put it in the hands of a professional who knows how to invest it. That's about all we have time for today. The key takeaway is that time is money, money is time, money is just a storage form of energy which came originally from the sun, just like that battery you charged up with electricity that came from the sun. It does lose its value over time. In the case of the battery, it loses its ability to perform work. In the case of your money, it loses the ability to purchase things. Now I'm going to show you a brief video on using the Mac calculator to do some of these calculations. Also, please remember to subscribe to my channel. If you like it, leave comments. If you hate it, leave comments. Leave me questions. You can email me at thedoctorplace@gmail.com. Also, I'm going to put some links in the information below my video to 2 books that I think are awesome and are economics basically for non-economists. One of them is called Hidden Order: The Economics of Everyday Life by David Friedman. And the other one is called Economics in One Lesson, written by Howard Hazlitt. It is a classic. Thank you very much. Okay, so I just want to show you a quick review on some of these calculations. I'm going to take 1.02 to the 20th power. And so I'm going to do, this is a Mac calculator, comes standard with a Mac, 1.02. You want to take it to 20th power. This little button here gives you an x with a y exponent. The y part is going to be that 20. So I just hit that, and then I hit a 20, and then I get the number. Okay, now I want to divide 5 by this number. If you notice in the rest of the video, I rounded up before I divided, and in this case, I'm not rounding up before I divide. We're going to get a little bit different result. That's okay, it's the same thing. So anyway, now I'm going to divide this. So first I'm going to divide 1 by x, with x being the number in the result panel. Then I need to use my numerator of 5. Well, how do I divide 5 by that? I actually multiply this by 5. And now I get my number. And you can see it's $3.36, just a little bit different than what we had before, but gives us the exact same essential results.